Just getting all my screens in place. So, good morning. Welcome to the Danimex webinar. We're going to talk a little about the technologies that MOTOTRBO actually offers for us. So let's go down to the business and switch off the camera. You do not want to see me, you want to see the presentation, I believe. So, let's go. You have all been muted. There's quite a lot of it. It's good to see so many of you on this presentation. We have a limited seating, so it's a matter of being here in good time. But you have all been muted. You have the opportunity to raise a hand. But I would much rather prefer if you ask the question in the field for Q&A that is below in the window. That's as it's shown on the presentation. The presentation that we have on right now is available for download, so you can actually download it and see. I can see somebody raised a hand. So we are recording this webinar. That makes it possible for us to have it available for evaluation internally, but also as later streaming for those who missed this event. So those are the things that we need to do. So remember, you can download. You can ask a question. Ask a question as we go along, then you don't forget. And in the end, we'll have a look at the questions. So today, this is me, your presenter, Johnny Bungard. I'm going to talk to you about the technologies of MOTOTRBO. And we start sort of from Danimex. We have more than 30 years of experience inside the communication industry. We are very, very highly skilled professionals in all aspects of the technologies that we offer. We also provide training. We can provide classroom trainings. We can provide webinars. We can provide online trainings as well. This is a webinar, so we're just giving you a lot of good information. For the academy part of our product portfolio, you can find our courses inside of the academy folder on our homepage, danimex.com/academy, where we can learn more about the MOTOTRBO professional courses. So here you can reserve your seat. Reserving a seat is, as you can see, there's a couple that has been postponed due to the COVID-19 situation. And so we'll see if we can get started in the autumn. We still do not know if it's possible because of travel restrictions worldwide, but let's see how it goes. So the next MOTOTRBO training is scheduled for 7th, 11th of September. This is a very enhanced training, and it's our second release of it. If you do not know anything about MOTOTRBO, maybe that's not the course you should have. But we're actually able to, in these COVID-19 times, to offer you basic programming online. And that's a course you can buy. We also have the webinar list where you can register for the webinars. You are already there. There's the recording. You can view that. You can also sign up. Of course, you've done that. Otherwise, you would not hear my voice. So anyway, so there's a list of webinar recordings. The webinar recording is here. You can stream it from here, and here are the slide decks. But as I said, I've made the slide deck available for you already now. Under the Hytera courses, we are Hytera distributors for the Nordics. Then we have some trainings and also a webinar schedule on that aspect. Now back to my presentation. So what is DMR? DMR, Digital Mobile Radio. It's DMR Association who set up all the guidelines, all the specifications for the different technologies. And we have then the low-tiered license-free digital radios. We also have Tier 2, which is what we're mostly going to talk about today, but also Tier 3, which is trunking, true trunking with all the capabilities that are in a trunking environment. We'll discuss that much more later. So MOTOTRBO, we have a very comprehensive product portfolio, but also technology portfolio, and we are focusing on the technology now. And then next week, we will have a quick look at the products that are supported by the different technologies. So we'll have a look at that later. So what do you get from digital versus analog radios? First of all, the audio quality on analog is extremely good on the close distance. But when you start moving out, it starts getting, you get noise on the sound. So that is the sort of the line curve. It's degrading with distance. But in digital, it's ones and zeros, and there's some forward error corrections built into it. Then you can actually move in further and still get a good voice quality. So you can have better quality longer, but when you are 2 meters apart, the quality in analog is better than digital. That's how it is. You can have double the capacity on a single Simplex channel or a repeater channel, because we are doing TDMA. I'll come back to that in a moment. By using TDMA technology, that with the 5590 scheduling, you actually get 40% longer talk time on a battery, because you're not transmitting all the time. And then the features and the apps are through the roof. I mean, it's quite comprehensive. From analog days, we have to think out of everybody is on the same channel and all they're saying, hello, are you there? We need to move into the digital world and embrace all the technologies that we can actually have. So we can actually migrate from analog. So now we're already in the technologies. This is called dynamic mixed mode. A modern repeater can actually handle that. It can be set up to receive an analog signal, and then it will repeat analog, or it can repeat a digital signal and repeat digital. The only sort of limitation with this is that when an analog signal is occupying the repeater, the two digital time slots are not available, and vice versa. So it's a possibility in the transition period that you can run analog and digital side by side. You also need to recognize the fact that you can have all models of radios except for one has an analog fallback. You have the capability of have channel 1 being some sort of analog channel and channel 2 being digital on the same device. So it's very flexible radio communication systems that we are looking at. What do we get from digital? From digital, we have the opportunity for a private call. That's a one-to-one call type. It is private call is private between these two devices, and nobody can listen in. It's a matter of how the call is addressed. Because it's digital, we're sending a header containing some information about type of call, who we are calling, and who we are, and that's always in the communication. So we can go private call, we can also do a group call, and that group call is private within the group. And finally, we have the all call, which means you can, or we also sometimes call that broadcast call, because we can compare it to a television, for example. A television is a broadcast. It's broadcasting. You cannot respond to a broadcast call. So that is all call available in the technology. And here's a big list, but it's just to give you can enable and disable devices over the air. All these capabilities are available throughout all the technologies that we have, as long as we're in digital. Disable and enable, Remote monitor, that means you can eavesdrop, so you can spy on a radio. Radio check, that's just like a computer ping. You can ping, is the radio online or not? All this can be done from a portable with a keypad. On the infrastructure side, we can also do over-the-air programming, which means that you can have one base radio connected to your computer, and then you can program the whole fleet of radios. For example, you are now implementing a new site in location X, but you didn't have the frequencies when you deployed your radio system. If you prepared your radio system for over-the-air reprogramming or over-the-air programming, then you can actually add the channels to all the radios in the fleet, and you do not have to recall them. Can you imagine the time saving that you can have in this environment? You also have location services that with a third-party software, it's possible to view location of the different radios within your fleet. And that's a topic that we are going to take off later in the series. Text messaging. All display and limited display radios can actually send and receive text messaging between each other. Even a non-display radio can send a predefined text message to a predefined radio. Job ticketing, that's a little more advanced text messaging where you can send a task to a radio, and that radio can respond, started the task, stopped the task, completed the task, and you can keep track of the work process. Then we have encryption. The radios are built with encryption. There's a basic encryption, and then there's a 40-bit encryption that gives the amount of combinations that I'm not trying to read out to you. On top of that, there's also AES encryption available, and that requires export license to the end user certificate. Radio to telephony is also available. There are two versions of it. One is the directly on the repeater, and the other one is the SIP client, SIP trunk solution using third-party software. So there's a lot of technologies, and you need to think about stepping out over the edge of the analog world to obtain all these facilities. By the way, one of the questions that I often get when I run these training courses is that, can I do over-the-air programming on analog radios? And both yes and no. No, you cannot do it on an analog channel, but you can have a digital channel within the programming of the radio and utilize that for sending the over-the-air programming commands. Then there's a portfolio. On the left side, you see what systems do we offer, and that is what the topic is today. In middle and right side, that we can look a little more about applications and subscriber radios, but those are later topics in the series that we have planned. First, in analog, you can have two radios communicating in analog mode, talking to each other in direct mode without any repeater or infrastructure involved. You can also do that in digital, but at one stage, Motorola introduced DCDM, Dual Capacity Direct Mode. Dual Capacity Direct Mode is a way of offering two simultaneous calls on the same frequency with a 12.5 kilohertz channel spacing. So, but how can that be done? Because how does the radio know the timing? Which one is time slot 1 and which one is time slot 2? There's a beacon environment inside of the technology that sort of says, hello, if the timing leader says, hello, I'm transmitting now on time slot 1, everybody registers this and rebroadcasts the timing information to the other parties in the Simplex channel. That is how that you can have two simultaneous calls happening on the same Simplex channel. So that is DCDM, Dual Capacity Direct Mode. When you are in a simplex environment, you have radio to radio, maybe in analog, or you may have switched to digital. Many times there's a limit in the communication distance that you can have in a direct mode operation. And that can be extended by the means of a extended range direct mode repeater. It's a facility that you can install inside of the repeater. And now it could be an environment you cannot get another frequency, so you only have the same frequency. But then you can actually put a repeater on a location that's sort of central in the communication, or it could be in a vehicle moving about. And then we would have the radio of radio 1 is transmitting on slot 1, and it's being received on slot 2 on the other radio because the repeater repeats. So it's actually switching between time slots. And that means that you can actually extend the communication quite the distance by having a simplex repeater. There's one limitation in this. It has to be a very specific relay changing over between TX and RX, and it's a solid state relay. And currently Motorola has it only as a part number for the SLR 1000. Now I'm jumping ahead, but we come back to the infrastructure next session. Then we're looking a little on the systems. In here we're going to look at each single or each IP site connect and conventional. Basically, conventional single site in analog or digital mode is what we have. But we also have IP site connect, which is a multi-site environment where we can extend the coverage of the same amount of channels. But we're going to look a little more deep into that. So let's first go to IP site connect, or actually. So in analog, we have a repeater. This repeater is receiving on frequency 1 and retransmitting on frequency 2. This gives us one channel and one frequency pair and one talk path. Switching to digital, we suddenly get 2 time slots, and to a radio that's equivalent to 2 channels, but we're using the same frequency pair and the same channel spacing as we had before. This gives us 2 simultaneous talk paths, and they do not disturb each other. So this is the digital TDMA technology. If I put up 6 sites, they would all have local area channel, LAC is local area channel, and they would not be interconnected. If we choose to interconnect them by the means of IP, then we would simply get 2 virtual channels that will cover a large geographical area. It doesn't mean that we can increase the capacity, we can only increase the coverage. So it's just like having one repeater, but with a huge coverage. It's drawn as pearls on a string, but this could also be a city where you link them up. It's just because it's easier to draw the lines in straight lines as opposed to drawing a lot of curly wires. So this is what we get, and that is now called wide area channels, WAC. It's a possibility within the programming to define whether you should have wide area channels on both time slots, or some of them should be wide area channels and the other ones should be local channels. So you have the opportunity to select that time slot 2 could be local channels. Subsequently, then they could do the local communications, the guards, etc., which doesn't have to communicate across the big platform. So let's just have a quick look at what happens on the communication. If we imagine that we have this radio that is broadcasting on time slot 1, that's being rebroadcast on time slot 1 to this radio because it's the same talk group, and by accident they're on the same repeater. But at the same time, it's also going to time slot 1 on the other or any of the repeaters in our IP Site Connect network. At the same time, the communication on time slot 2 is also being rebroadcast on time slot 2 on the other side. Plus, it's of course being rebroadcast in the local environment. So that is how the two channels. So it's physically just two channels, and then you can sort them out. One of the things is that everything that when you're talking IP Site Connect or single site digital repeater, then it's on a timeshare basis within the time slot, within the channel. So we have a limitation of how many talk groups it's practical to put on a specific channel. I have a question from which I actually can address right now. The question was, how many sites can you join together in one system? I will just delete the drawing 1 second, please. And then I will go back to. So let's try and go back to the slide deck. How many sites can you link up in this environment? Motorola specification says 15 sites. So you can have 15 sites joined into the same IP network. But there's another limitation to this because we cannot do it with satellite. We need to have maximum of 90 milliseconds between any given point within the IP structure. So that was a separate process. So let's have a look at the next slide here. We had this one. I hope that answered the question that came in, but thank you for asking that. It was a very good question. If you imagine that you have two sites and they are automatically, or they are linked up via IP, 90 milliseconds max, and site 1 is moving from site, one of the cars, the Charlie car, is now driving into another zone, it will automatically detect the new zone. So it moves to the other side and then be communicating. So it's possible to roam across the platform. There's another question. How many talk groups can be created? How many talk groups can be created? Well, the DMR standard specifies around 16 million talk groups, 16 million individual IDs in IP Site Connect or single site environment or Capacity Max, which we cover to later. So you can actually have an awful lot of groups, but how many are practical on each channel is depending on the usage. The next topic that I would like to address is Capacity Plus. And Capacity Plus is in two steps. One is single site or multi-site. Now, when we are in the environment where that the two slots that we had available are not enough for our communications to have all the talk groups to be able to utilize this, because the talk group is forced on a slot. It's forced on a channel. However, when we switch to Capacity Plus, we are appointing, or the system is appointing, a controller. And that controller is running, actually the controller is a joint venture between all the repeaters in the environment. And they agree upon themselves which one should be the rest channel. So the rest channel is now running. The rest channel, every device on the network is joining the rest channel. That's what it's being told. So the rest channel is appointed. It's 4 repeaters on the same slot. We have antenna combining equipment and all this. So we have a rest channel. All the communication that happens will happen on the rest channel. So in case of somebody wants to engage in a call, The non-active parties will be appointed a new REST channel and they will move to there. And this means that the old REST channel becomes the voice traffic channel. This means that we can now communicate on the old channel. And the REST channel is resting and waiting for the next call to happen. Whether it's a group call or private call or all call, then it's just resting and waiting for the next call to happen. That means that the 4 or 8 or how many slots we have available are suddenly shared amongst the resources, and that's a part of the trunking environment. But because it's a REST channel, we have some limitations as well, because there's no priority. We do actually have transmit interrupts, so we can actually interrupt and knock off a call on the network. In case that you want to have, let's assume that we have 3 calls going on a 4-slot environment. The REST channel is the only remaining call left. And now a new call is going on, and the remainings are sort of dropping out, and this means that we can utilize all the channels for the calls. It's dropping out, but it's not dropping more out than it. You can do a transmit interrupt if you press the emergency call, or if you have priority button assigned to your environment. And as soon as somebody stops talking, that will be the new REST channel automatically resumes operation. There are some questions that are popping in, which is actually valid to take in this level now. On Capacity Plus, can you use the same channels for data, or do you need different repeater for data? It's a very good question. If you do not specify anything else, you can have, let's say, 3 repeaters voice or 4 repeaters voice, and then the data, which data in this case would be GPS location and other factors, would be running on the voice channels. Or you can choose to allocate a full repeater to offload the GPS data onto. So then we shift the data to a revert repeater functionality. So that is sort of answering that questions. All the questions that you write to me are being registered, and we will address them after the event as well. A programmer can define the time slot required. That is negative because everything is shared. You cannot allocate a specific time slot for a specific user. Everything is shared equally. Okay, so that's just answering that question. Now, in a Capacity Plus, how many repeaters can you have at a single site? You can have up to 8 voice repeaters equal 16 time slots for voice, or a combination of voice and data. In addition to this, you can have actually more than, but we normally specify 4 data revert repeaters. So you can have 12 repeaters on the same location handling voice and data. So Capacity Plus can have up to 12 repeaters totally. You can actually have 24, but then it becomes complex. And there's an additional question right now. There's somebody with no data revert repeater. That means that the GPS is being transmitted on the current REST channel as a call. Now I'm shifting to link Capacity Plus. That's the old word for it. Now it's called Capacity Plus Multisite linked. Anyway, so this part of the presentation is relatively old, so I just left it in. So if you imagine that you have 3 sites with a combination of voice and data repeaters or pure voice repeaters, on the same. Each of the sites, there's one repeater functioning as a rest channel slot. So in case a radio wants, oh, by the way, we need to link them up with a router, and the only approved router today is HP's Hotel Papa, HP, MSR, Mike Sierra Romeo 2003. That is the only approved router. No Microtech, no Cisco, no other things, because it has to be, it's the only one that's approved today. So, in case that somebody wants to engage in a call, a new REST channel is appointed locally. The repeater on side 1 is communicating to the REST channel repeaters on the others and say, do you have capacity for me, please? So a new REST channel is appointing on the other 2 sides, and the repeaters will respond back and say, yes, I've got capacity. And then the call will go through. This means that all the 3 repeaters that before was the REST channel is handling this voice call across the system. That's a wide area group voice call. The limitation of a system like this is that we have to have fixed groups. This means that we have to have groups on all sites, and if it's not present on the site, then that site will not be active in the call. Or if this call was a private call, then it would be it will only be the 2 radios involved that would key up the repeaters. If the 2 radios in a private call are on the same site, it will only be that site lighting up. There's a question, how long a maximum distance of repeaters can transfer data? I'm not sure I understand the question completely, but let me try and address it in 2 ways. The sites should be very close proximity, okay? So they should be in the same cabinet. Only one switch joining them together, and the routing making the communication pass on to the other sites. The router is essential because there's a lot of signaling happening inside of this, behind the router. So the router is there to prevent unnecessary communication coming back into the other sites. And the data, voice and data, is the same distance on the repeater system as well. I'm just looking at questions as well, because there are some that are very well relevant to now. I need to talk about Capacity Plus. Is there a way to have a fixed control channel? Negative. You do not have a control channel. It's called a REST channel, because control channel is transmitting 24/7. A REST channel is transmitting in bursts and just saying, hi, I'm here. So you please do not confuse control channel and REST channel, because control channel is something else. No, you cannot fix the REST channel. However, you can give a specific repeater higher priority on the REST channel appointment. So, but it's not fixed. It's a dynamic environment. There's a question about the HP equipment. That one I would like to address in writing, because there's some specifications that the equipment has to meet, and I do not have them live. Wow, but it's good. Thank you for all the nice questions. It's very relevant questions. Now, I said that all sites would have to light up if it's relevant for the groups to be on that site. But capacity Plus and Link Capacity Plus has an opportunity to say, for example, that group call ID number 10 should be available on all the sites in the environment. But for example, group call 30 should only be available on site 1 and 2. Then it would not be a what you call it would not be rebroadcast to the sites. And if a radio is attempting to make a talk group or a call on a talk group that is not allowed on the repeater, it will simply not be allowed to make the call. So that's how it's done. So some planning is required. And what you also saw on this slide is that you don't have to have the same amount of repeaters on all locations. You can have an HQ. This HQ can have, let's say, 20 talk groups, X amount of repeaters, let's say 5 repeaters for voice. And then you can have another site which is just the warehouse, and there's only the warehouse staff and the drivers that I actually need to communicate on there. And then you can have fewer channels, but then you need to restrict which talk groups are addressing which channels. Okay, now normally I would switch directly to the next level, which was capacity max. However, there are some technologies which I promised to tell you a little about. And these technologies are something called voting. I'd like to explain to you what voting is. If you imagine you have an environment, maybe a hilly environment, and remember our repeater can do up to 50 or 100 watts, okay? But our portable is only 5 watt in return, which means that we will have a limitation to the coverage that we can offer. So if you imagine that you have the voting transceiver being in the center, and then you have so let me try and break this picture down a little. So 1 second, I'll make a drawing. I'll draw on this one. So this part is the main transmit and receiver repeater. Okay, that is transmitting this far. It's transmitting out, but because a portable only has 5 watt in return, then it will only have this coverage, which means we are wasting a lot of energy. Because, or of course, if you have a mobile fleet as well, then that energy is not wasted. But if we consider only portables, then it's possible to set up some extra ears and create an IP link back to the main site, and then all the signals will be detected by the different ears, and then the best signal, the strongest with the best bit error rate, will be rebroadcast on the main site. So that's voting in effect. This means that we have an opportunity to increase the coverage by putting up some extra ears. So if you imagine, so how do we do that? Let me try and take the next slide. Now, try again. If you had IPSC Connect, you can have voting transceivers on the main location, and then you can have, this drawing actually indicates that you should have 4. That's not true. You can have a mixture. Maybe there's only 1 required for making full coverage in location X or whatever. So I have another slide on that in a moment where I try to explain a few more things. If you have capacity plus, because you have the capacity plus and you have randomized rest channels, then you need to make sure that all your satellite receivers that are located out on the different location, you need to make sure that all of them are there. The beauty about this is that you could put up IP site connect repeaters. However, if you do that, or here you could put out another IP site connect repeater to give footprint coverage, but then you need extra frequencies. The beauty about voting is that there's only one set of frequencies. Those frequencies are belonging to the main site, the transmit and receive site. Those are the frequencies, and that will otherwise we need to get more frequencies, and frequencies can be an issue in some countries. In Capacity Plus, we can also have the same environment, but let's try and take an example of a scenario. And this is my own little, so if you imagine that you have a single site and you can see the black circle, that's the footprint for the transmit part of the main site. The red circle is, or not circle, but the red contour is maybe the, I'm sorry, it was not intentional that it should look like Africa. But anyway, and then the striped are where we cannot respond back to the main site. So then we have our system that's consisting of a receive multicoupler. Then we have 4 repeaters, and then we have some transmit combining equipment. Okay. Now, so the example that I've made here is that we have 4 repeaters. Then we have 4 Capacity Plus single site licenses built into each of the repeater. We have an antenna receiver multicoupler and an antenna combiner. Then we need 4 pairs of frequencies, and in this environment we are assuming 2 antennas. The next step is, if we want to cover the grayed out or striped area, we need to make up a separate location. So we can do that by upgrading everything to Capacity Plus linked. So that requires us to have 4 repeaters, but we also need to have Capacity Plus linked for the new site, but we also have to have Capacity Plus linked for the old site. So we need to upgrade the license on the main old site 1. Combiners, multicouplers, antennas, etc. And 4 extra frequencies. So if you have this environment and you know that the transmit is going into the coverage area, but the receive is not coming back. But if you do voting, you can save some money. If you do voting, all you need to do is set up 4 more repeaters, having a receiver multicoupler and 1 antenna. And of course, these 2 sites needs to be linked via IP. And the IP is actually, the delay here is 40 milliseconds between any of the voting receiver sites. And then you need to install a voting license in the main repeater. But as you can imagine, you don't have to spend the money on a combiner. You don't have to buy new frequencies or obtain new frequencies, because you cannot reuse the frequencies, because you never know which slot is active on which site. So you cannot have it like that. And then you just need 1 antenna. If you imagine the second site would be running off solar, then you really don't need that much energy to run this little environment. And you do not license and you do not need any licensing on the satellite receivers on the remote site. There's a question about the antennas. If you have a very wide spreading of frequencies, it can be difficult to obtain a duplex filters for 1 antenna working. So I've left it out of the drawing. That is the only reason why. In Link Capacity Plus, you can do the same, but again, if you have 2 repeaters on site 1, you also need 2 repeaters on all the satellite receiver stations. The same thing applies for the second site. We have actually had some issues, because what you could imagine is maybe there's a sort of a ridge or something in that ballpark that is what is causing this obstruction. There could be a high point here that causes that the portables cannot respond back or something like this. And instead of having a completely new site, you can actually benefit from having voting. I can see with the topics that I have remaining that we may run a little over the 1 hour that I hoped for, but let's continue. So now we're switching to capacity max. Now we're moving into a lot more sites. The 15 sites that we can have in Capacity Plus or 15 sites in IPSC Connect is the limit. I would never consider Capacity Plus as a country environment. I would consider this as a regional environment or a city. And then it's possible using some of the control room solutions to join the systems. So you have one, like here in Denmark. Sorry, I'm taking Denmark. You don't know Denmark. But anyway, we have Copenhagen, the capital city, right? Then we have Odense, which is the second largest city, no, third largest. And then we have Aarhus. So those are the three main cities in Denmark. And if we imagine that we make a multi-link Capacity Plus environment in Aarhus, one in Odense, and one in Copenhagen. So every foot patrolman, any policeman walking around in Copenhagen doesn't need to be able to communicate to the people in Aarhus or Odense. So we will just let them be regional, but it could be that a private call between a user in Odense and Copenhagen would be an option, then that can be patched. So, but again, that is not so, then we can have multiples for 15 sites. 1 second. In Capacity Max, that is the tier 3 generation of Motorola's trunking solution. And now we've moved into having very specific control channel and backup control channels and all this. And that is what is inside Capacity Max. It's leaning onto the DMR standards. And that means that Capacity Max can be compliant with other manufacturers' Capacity Max or other tier 3 environments if you buy that option, because Capacity Max is a proprietary option, but it also can work in generic tier 3 operation. So let's just compare the three. If you look at capacity on the IPSC Connect, you only have 2 channels, and then you can have 15 sites. On the Link Capacity Plus, it actually says that you can have 16 plus 24 channels, but it can maximum have 20 in a system. It's sort of a little complex. That's the reason why we say 4 data channels. And the system type is conventional. You are forced on the channel, whereas in Capacity Plus or Link Capacity Plus, it's trunking. We do not have a specific controller. You have a REST channel in the Link Capacity Plus and Capacity Plus. And then you have not really any authentication. There's something called repeater access service, I think it is called. But there are some facilities here. But when you move to Capacity Max, you can have 250 sites in the system. You have a centralized controller which can be redundant. You have full trunking with a dedicated control channel. And then you have full subscriber access control, which means you have a database. Every radio switching on is registering on the database and being authorized to transmit. We have queuing and priority environments, etc., etc. So suddenly it's a much more comprehensive package. So the architecture is that you have it's scalable. You have multi-sites. The repeaters have to upgrade it for capacity max. The radios need to have a license for the capacity max, and then it will be working along the way. Calls are not being handled by the processor, but they are being authorized. So you can have up to 15 voice and data repeaters per site, and that's a combination, or you can have 6 additional data repeaters per site. 15 voice is actually 29 talk paths plus 1 for control channel. So that's quite comprehensive. It's quite advanced. I said before that the capabilities are compliant with other manufacturers, which is true, because there's an interoperability testing going on between manufacturers where they test everything, whether they are matching the specifications, and that's the list. I will not read that out to you. You can see it in the slide deck, which I assume you already have downloaded. So you're reading ahead from me. And if you are unsure, the download is available on your pop-up screen. Now, which products are supported by the Tier 3 environments? The SLRs, all the 1,000, 5,000, and 8,000s are infrastructure components. There needs to be a server and some other stuff. And all the 4,000 series and the E versions and also the mobiles equivalent will actually work on this one. And also DP3441 and DP3661E will also be compliant. So we are moving from, actually I'm missing one thing there, which could be Simplex, radio to radio communication, all the way from single site environment and up to IP site connect link capacity plus, or if you have an MPT 1327 system with an option board in the new radios, then you can shift all the way up to capacity max. And if it's a 4,000 series radio you have in your hand, then it could do it everything. It could smooth integration. So let's just recap the technologies. If you imagine that on-site is MOTOTRBO single site repeater, okay? That will give us voice, some sort of data, some privacy, but not very high density, and some applications. If we want to expand the coverage, then we shift into IP Site Connect, where we can increase the coverage, but it doesn't increase the capabilities or that people that are able to utilize the system. If you want to do more on the same site, then you switch to Capacity Plus. That gives you higher density on the location. If you want to do that on a wider scale, then you do IP Site Connect. And as I said, do not consider Link Capacity Plus as a multi-site countrywide system. Then it's a small country. It is designed for region use. Then we move to Capacity Max. Capacity Max is still nationwide, and all the blue colored here can be utilized on the same device. So that is the Capacity Max. And then we can actually replace all our hardware and infrastructure and go Tetra or Astro. So that is sort of the environment. There's a question about a product. It's actually for next week's event. The SL4000 doesn't have a GPS. That is correct. The GPS 4000 is more considered as the hotel environment managing solution, and it doesn't have a GPS. But the E version does have Wi-Fi and Bluetooth. That was a question that was responded. So Tier 3, true Tier 3 is moving from Capacity Max and upwards. So now we are shifting to the Q&A. I have been able to sort of follow some of the questions already online, and we will address that in a moment. I'll just expand the screen of the questions. If you by any chance are you viewing a recording of this, then please do not hesitate to write to webinar@Danimex, and then we'll address the questions. This is a live presentation. All the features that I showed for the digital, they do not actually work in analog mode. That is a truth. First of all, multi-site environments, all this is not available in analog. But we do actually have SELECTIVE in some of the radios. So if you are used to working with the analog SELECTIVE system, it can actually do some of the things for you, like addressing calls and having PTT ID, kill and revive radios. So there's a question about what is the maximum distance in kilometers that a Simplex channel can transfer voice. Ooh, that's always the question. If you ask a salesman, he will say one number, and if you ask a technical person, he will be a little more, how can I say that, conservative. And I'm conservative. A portable can be anywhere between 3, 5, 6, 7, maybe even 8 kilometers. But remember, there's the through the air attenuation, there's the antenna height, maybe it's at the belt, maybe you have it in front of your face, then that's 1.5, 2 meters high where the antenna is, and then there's what obstructions are there in the path between the two devices. So portable to portable could be anything. So I'm not really going to say a lot of promises on that one. There's a question about OTAP. OTAP can be carried out on all the 4000 series, 3000 series of the recent version. There's a very specific question, and I think we will address those questions in a separate email on a scenario. Ladies and gentlemen, that takes me to the end of the presentations. It took us 1 hour to go through this. I hope you benefited from this, and I hope you have the presentation downloaded. The presentation will be at our homepage, so we will make sure that it's on the homepage as well. And once I've rendered this video, it will also be available, and you can show it to your colleagues, etc. It's been nice to seeing you all. I hope that we can meet again in 1 week's time, where the topics are Motorola MOTOTRBO products. Thank you very much. Enjoy your day and stay safe.